I spent 40 years trying to find a way around it, not because I was naive, because I understood exactly what it meant if there wasn't one. Time is the prison, not space, not distance, not the technical challenges of building a spacecraft or finding habitable planets. Time. The speed of light guarantees that even if we solve every other problem, propulsion, life support, navigation, survival, we still can't reach the stars. Not in any meaningful way. Not in a human lifetime. Not even close. And the worst part? The universe doesn't care about our ambition. It doesn't care that we've looked up at the night sky for millennia dreaming of other worlds. The laws of physics are what they are. Absolute, unbreakable. I spent decades searching for exceptions, loopholes, mathematical tricks that might let us slip through. What I found instead was that the limit isn't cruel, it's information. It's the universe teaching us what reality actually is. Let me show you why time became my obsession, and why it should terrify you too. In 1967, when I was still walking, I sat in a lecture hall at Cambridge, listening to Roger Penrose describe how stars collapse into singularities. The mathematics were elegant and brutal. Once certain conditions are met, collapse becomes inevitable. No force in the universe can stop it. I remember staring at those equations and thinking, if collapse is inevitable in one direction, what does that mean for expansion in the other? What does that mean for time itself? That question stayed with me, not just as an abstract puzzle, but as something deeply personal. Because by then I was already noticing the first symptoms. My body was beginning its own inevitable collapse. And I was studying a universe where inevitability was written into the fabric of space-time. The speed of light, 299,792,458 meters per second in a vacuum, isn't a speed limit like the ones on motorways. It's not a suggestion we might exceed with better engineering. It's the rate at which causality itself propagates through the universe. It's the speed at which now becomes then. Every moment, everywhere, is separated from every other moment by this fundamental interval. You cannot go faster because there is no faster. There is only this speed, and everything else is slower. I proved this to myself over and over, not because I doubted Einstein, his math was impeccable, but because I needed to understand what it meant for everything I cared about. Could we visit other stars? Could we explore the galaxy? Could humanity survive by spreading beyond Earth? The answer kept coming back, not in the way we want. Here's where it gets truly claustrophobic. Imagine you board a spacecraft capable of traveling at 90% of light speed. Remarkable engineering, unprecedented achievement. You point it toward Alpha Centauri, our nearest stellar neighbor, at 4.37 light-years away. From Earth's perspective, your journey takes just under 5 years. From your perspective, time dilation helps. Your clocks tick slower, so you experience maybe 2.5 years of subjective time. But here's what happens to everyone you left behind. 5 years pass for them. Minimum. If you want to come back, that's another 5 years Earth time. A decade gone. And that's the closest star. The nearest potentially habitable planet we've found? Decades. The center of our galaxy? Thousands of years Earth time even if you're traveling at near light speed, and your subjective time still stacks up to an entire human lifetime. Not faster, not slower, exactly that speed. The speed of light is the speed of time itself. In 1985, I made a bet with Kip Thorne about whether time travel to the past was physically possible. I bet against it. Not because I'm pessimistic, but because the mathematics of general relativity show that every scenario allowing backward time travel requires conditions so exotic, negative energy densities, infinitely long rotating cylinders, traversable wormholes, that they're effectively impossible. Kip disagreed. We wagered a subscription to a magazine, something appropriately frivolous for such a serious question. I lost that bet in 1990 when Kip and his colleagues found a mathematical solution that didn't immediately break physics. But here's what we both understood. Finding a mathematical solution and building a working machine are separated by a gap the size of the observable universe. The equations might allow it in principle. The universe says no in practice. Time travel to the future, though? That's not just possible. It's mandatory. Every moment we're traveling forward through time at 1 second per second, but speed this up and you can jump ahead. At 90% of light speed, you travel roughly 2 Earth seconds for every 1 second you experience. At 99%, it's 7 to 1. At 99.9%, it's more than 20 to 1. Get close enough and you can travel centuries into Earth's future while aging only years yourself. The problem is getting there, and getting back, and having anywhere to come back to. This is where the terror lives, not in the speed limit itself, but in what it does to human civilization across cosmic distances. Let me take you inside the numbers. To accelerate 1 kilogram of mass to 90% of light speed requires roughly 1.8 times 10 to the 17th joules of energy. That's the energy output of a large nuclear power plant running for several years just to move 1 kilogram. A spacecraft capable of carrying humans? We're talking thousands of kilograms. The fuel required to accelerate that mass and then decelerate it at the destination becomes its own problem. You need fuel to move the fuel. The ship grows exponentially heavier. The energy requirements spiral upward. By 1999, I'd seen enough theoretical designs to know the pattern. Every serious proposal for near-light speed travel required either converting the entire mass energy of Jupiter into propulsion, building a laser array stretching across our solar system to push lightweight sails, or inventing entirely new physics. None of these are impossible in principle. All of them are impossible in practice for any civilization remotely like ours. But suppose we solve it. Suppose we build a ship that can reach 99% of light speed. We point it toward a potentially habitable planet 50 light-years away. From Earth's perspective, the journey takes 50 years out, 50 years back, a century. From the crew's perspective, time dilation helps, maybe 7 years out, 7 years back, 14 years of their lives. They return to Earth a century later. Everyone they knew is dead. Their children, if they had any, are elderly or gone. The civilization that built their ship has transformed beyond recognition. Languages have evolved. Governments have risen and fallen. Technology they took into space is museum pieces. They are strangers in a familiar place that's become utterly alien. This isn't tragedy in the dramatic sense. It's geometry. It's what happens when two reference frames experience time at different rates, and you're conscious in both. In 2006, I wrote that the survival of the human race depends on spreading to other stars. I meant it. Still do. Earth is fragile. Asteroid impacts, supervolcanoes, our own self-destructive tendencies, any of these could end us. We need backup, we need redundancy, we need to become a multi-world species. But the speed of light makes this almost impossibly difficult across human timescales. Generation ships might work, massive habitats that travel for centuries while populations live and die aboard them, with distant descendants finally arriving at new worlds. But this requires maintaining a stable society inside a closed system for longer than most civilizations have existed. It requires the journey itself becoming the civilization. And it requires accepting that the people who launch will never see the destination. Neither will their children, nor their grandchildren. Dozens of generations born in the dark between stars. Some proposed solutions try to sidestep the problem. Suspended animation, slowing metabolism so the journey subjectively takes months instead of decades. Again, not impossible in principle. But every organism we've tried to freeze and revive at a cellular level dies. The ice crystals tear through membranes. Information is lost. We can freeze embryos successfully, but not conscious beings with memories and identities. Not yet. Others proposed warp drive. I was intrigued when Miguel Alcubierre published his paper in 1994, showing how space-time itself might be contracted in front of a spacecraft and expanded behind it, creating a bubble that moves faster than light, without the ship inside it ever exceeding light speed locally. Brilliant mathematics. Genuine creativity. There's just one tiny problem. It requires negative energy density. Not just negative pressure, we have that with dark energy, but negative energy density, something with less than zero energy in a given volume. We've never observed it. Every attempt to create it produces infinitesimally small effects under extraordinarily specific quantum conditions that last for microseconds. Scaling this up to move a spacecraft? The energy requirements are worse than conventional travel. You'd need to convert multiple stars into this exotic negative energy somehow. The universe keeps saying no, just with more steps. I stared at my ceiling many nights, literally as my condition worsened and my mobility decreased, thinking about this prison. The fastest we've ever sent anything into space is the Parker Solar Probe at around 430,000 miles per hour relative to the Sun. Sounds fast. It's 0.064% of light speed. At that velocity, reaching Alpha Centauri takes more than 6,700 years. Reaching the potentially habitable planets we're discovering with Kepler and TESS? Tens of thousands of years, maybe hundreds of thousands. We are biologically adapted for lifespans measured in decades. The universe offers us distances measured in lifetimes it takes light to cross. The mismatch is staggering. But here's what I realized, slowly, over decades of butting my head against these equations. The limit isn't telling us to stop. It's teaching us what the universe is made of. Time and space aren't separate things that happen to exist together. They're woven into a single fabric, and that fabric has a structure. The speed of light is that structure made visible. It's the exchange rate between space and time. Move faster through space, you move slower through time. Move faster through time, you can't move through space. They balance. Always. The equation stays consistent. Einstein showed us this in 1905. Not as speculation, but as measured fact. Time actually, physically, measurably runs slower for objects in motion relative to stationary observers. We've tested this with atomic clocks on aircraft, with particles in accelerators, with GPS satellites that need constant correction because they experience time differently than receivers on Earth's surface. Every experiment confirms it. The universe operates this way, which means the speed limit isn't arbitrary. It's revealing something about the fundamental structure of existence. Causality must propagate at a finite speed, or cause and effect become meaningless. Information must travel at a maximum rate, or the universe becomes paradox. The speed of light is the speed at which reality maintains consistency with itself. I spent years looking for exceptions because I hoped we might slip through some mathematical crack into faster-than-light travel. What I found instead was deeper understanding of why the crack doesn't exist. The more you study relativity and quantum mechanics together, the more you realize how precisely tuned the universe is. Change one constant, the speed of light, the strength of gravity, the mass of an electron, and chemistry stops working. Stars don't form. Atoms fly apart. Reality as we know it cannot exist. We're not imprisoned by arbitrary rules. We're shaped by the only rules that allow complexity and consciousness and the ability to ask questions about cosmic speed limits in the first place. Does this make the future less frightening? No, it makes it more honest. If humanity spreads to the stars, and I believe we must try, it will happen slowly, across generations, with long silences between worlds, as light-speed signals take years or decades or centuries to cross the gaps. Earth and its colonies will drift apart, not just spatially but temporally. Cultural evolution will accelerate differently. Within a few centuries, the descendants of humans on different worlds might have less in common with each other than we have with our ancestors from 1,000 years ago. The species will fragment, not catastrophically, but inevitably. We'll become not one humanity, but many humanities, separated by time as much as distance. Communication will be possible, but delayed. Coordination will be impossible. Each branch will face its own challenges, evolve its own solutions, become its own civilization. This isn't the future we imagined, not the one from science fiction where sleek ships zip between stars and galactic empires maintain constant contact. That future requires faster-than-light travel or communication. Physics says no. The future we actually face is slower, lonelier, more permanent in its separations, but also perhaps more interesting, because it means we're genuinely exploring the universe, not just visiting. We're committing. Each colony that succeeds becomes its own experiment in what humanity can be, given time and isolation and different environments. Evolution in action. Not biological evolution alone, but cultural, technological, philosophical. The speed limit doesn't stop exploration. It just makes exploration mean something irreversible. I used to find this depressing. The more I studied cosmology and fundamental physics, the more I understood how constrained we are, not just by light speed, but by entropy, by the cosmological constant, by the finite resources in our cosmic horizon. The universe is vast, but not infinite in ways that matter to us. Accessible space shrinks as expansion accelerates. Eventually, distant galaxies will recede beyond our ability to ever reach them. No matter how fast we travel, we have a window, a few billion years, cosmically speaking, a brief moment when the universe is old enough to have formed complex structures, but young enough to still be explorable. We happen to exist during that window. Not because of design. The anthropic principle explains why observers only exist when conditions allow observers. But because we're asking these questions during the only era when they're relevant. The terror isn't that the limit exists. The terror is that we understand it. We can measure it precisely. We can calculate exactly what it means for our future, and we're still bound by it absolutely. My body taught me about limits, about how it feels to push against constraints that won't budge, no matter how stubborn you are, how clever, how desperate. I lost the ability to walk, then to use my hands, then to speak with my own voice. Each loss was absolute, irreversible, no loopholes, no exceptions. But within those limits, I found what remained. My mind still worked. I could still think, still calculate, still imagine. I could still contribute. The limits didn't define what was impossible. They defined what was actually there, once you stopped mourning what you couldn't have. The speed of light is the same. It defines reality. not our wishes, but what actually is. We can work within it. Generation ships, if we solve the political and social engineering. Suspended animation, if we solve the biology. Seed ships carrying frozen embryos and artificial wombs, if we solve the ethics and accept that no living person makes the journey. Maybe some combination we haven't imagined yet. We can also accept it. Understand that becoming a star-faring species means accepting vast distances and deep time, that the cost of spreading through the galaxy is permanence, that every goodbye to Earth is final, not just for individuals, but for civilizations. When you look up at the night sky and see the stars, you're looking backward in time. The light from Alpha Centauri took 4.37 years to reach your eyes. The Andromeda Galaxy's light traveled for 2.5 million years. The most distant galaxies we can observe show us the universe as it was 13.8 billion years ago, shortly after the Big Bang. You're not seeing where those galaxies are. You're seeing where they were, across a gulf of time so vast that everything about them has changed except the ancient light still journeying toward you. That's what the speed limit means. It means the universe is fundamentally historical. Every observation is archaeology. Every measurement is memory. The present moment exists only locally, only for you in your reference frame. Beyond that immediate bubble, now is meaningless. Past and future mix together, depending on relative motion. Time isn't something that happens to the universe. Time is how the universe separates cause from effect so that anything can happen at all. I never found a way around it. The mathematics are too tight. The experimental evidence too consistent. The theoretical frameworks too interconnected. Change one thing and everything breaks. What I found instead was acceptance, not resignation, but honest recognition of what we're actually dealing with. The universe isn't designed for our convenience. It isn't designed at all. It simply is, following rules that emerged from initial conditions we're still trying to understand, rules that allow structure and complexity and consciousness and the possibility of creatures who can contemplate cosmic speed limits. We exist inside time. We're made of it. Our thoughts are electrochemical cascades propagating at speeds vastly slower than light, but following the same fundamental constraints. Information cannot travel instantaneously. Cause must precede effect. The future must remain open while the past stays fixed. The speed of light enforces all of this, not as punishment, but as foundation. Does it terrify me? Yes, because it means we're genuinely alone in ways we can never fully overcome. Any civilization that exists around other stars is experiencing its own now, utterly disconnected from ours. We could send signals, radio waves traveling at light speed, but responses take years. Conversations take generations. If anyone is out there, we're all shouting into a void that echoes back decades or centuries later, if at all. But it also means that what we do here, now, in our brief window of existence, matters absolutely. We can't rely on rescue from advanced aliens traveling faster than light. We can't escape our mistakes by jumping to alternate timelines. We're here, in this moment, in this universe, playing by these rules. What we build for real. What we destroy stays destroyed. What we learn becomes part of the permanent record carried forward by creatures, human or post-human or something we can't yet imagine, who inherit this universe from us. The limit isn't the prison. Time is. But time is also the gift. Because without it, without the separation between now and then, without the irreversibility of cause and effect, nothing would matter. Every moment would be every other moment. There would be no story, no progress, no meaning. The speed of light gives us time. Time gives us mortality. Mortality gives us urgency. Urgency gives us purpose. I spent my lifetime studying the universe's absolute limits. What I learned was this: the limits aren't walls keeping us imprisoned. They're the rules defining what's real, what's possible, what matters. Everything interesting happens at the boundaries, where desire meets constraint and creativity emerges from necessity. We can't escape time, but we can understand it, live within it, and create meaning despite, or because of, its absolute rule over everything that exists. That's the terror, and the wonder, and the truth.